Module 1, Lesson 14, Exercise 1. Consider the inequality x squared plus 4x is greater than or equal to 5. First instruction is sift through some possible values to assign to x that make this inequality a true statement. Here's the big deal. Find at least 2 positive values that work and at least 2 negative values that work. Now let's think about that. Our equation is x squared plus 4x is greater than or equal to 5, and I need 2 positive and 2 negative values. I don't know. I love 5 itself as a number. 1 seems like a good choice. I'm thinking maybe -1 and -5. Usually I'd pick 0 in a situation like this, but it said I had to have 2 positive and 2 negative. 0 is neither positive or negative. So now we're going to substitute 5 in for x. So we're going to say 5 in for x in these two places. Let me switch back. I think I can do this. Let's see if I'm cool enough. And then this is 5 squared plus 4 times 5 is greater than or equal to 5. That's putting 5 in. Here, let me, I'm going to speed this up a little bit. I need something squared plus 4 times that something to be greater than or equal to 5. That's the basic frame of my question, right? And in this case, we're plopping a 1 in there, 1 here, 1 here. Those two aren't so bad. Now I'm dealing with, I got a -1, so I've got to be careful. I've got to say something protected because of that negative sign plus 4 times that something is greater than or equal to 5. And I might as well set this next one up too. Something protected plus 4 times that thing is greater than or equal to 5. And in the case of the first one, we're putting in a -1 in both of these parentheses. And then we're putting -5 in this one because that's what we set this one up to be. All right, let's go. Why don't we show we're moving forward? We'll pick a new color, purple, eggplant this is. So this is 25 plus 20 is greater than, 20 is greater than or equal to 5. Well, that looks true. 45 plus 45 is greater than 5. So I like this answer. That was easy, true. Okay, I want you to think about the rest of these, and I'm going to give you a little hint. One of these does not work, and I want you to figure out which one it is. All right, let's take a look. 1 plus 4 times 1 is 4 is greater than or equal to 5. Ooh, this was cutting it close, but it is 5, and 5 is greater than or equal to. We have that option. If 5 is greater than or equal to 5, that's our true. That guy's okay. -1 squared. -1 times -1 is 1. 4 times -1 is -4. Is greater than or equal to 5. Oh, it looks like here is not a good thing. -3 is greater than or equal to 5. And that is false. So -1 is not going to work. I got a problem, and I want you to be thinking about it while we're doing this. This -1 wasn't big enough. It gave me a false statement. Let me see how the -5 does. So we have 25, -5 times 5, plus -20 is greater than or equal to 5. And that is 5 is greater than or equal to 5. This makes me feel like we hit a border. Notice we had a true over here. Oh, let me mark this true. So we're good here. This value is kind of causing us a problem. We can't use it, and we got to find 2 negatives. So I'm going to have to think about another one. And, you know, I'm lazy, but I want to pick something easy. I don't know. How about I pick -7? I know 7s. Those are kind of fun to square, right? So let's see. Something squared plus 4 times that something. Whoops, sorry. Clicked when I shouldn't have. and then 5. And I'm going to put in -7. And what do we got? And I got, change to another nice color, oops, 49 plus -28. Ooh, even if I didn't know what it was, right off the top, I can see this is much larger than 5. 21 is greater than or equal to 5. So I have true statements, wonderful true answers. We're going to use red. True for x equals 5, x equals 1, -5, and -7. Yay! The next question is, should your 4 values also be solutions to x times the quantity x plus 4 greater than or equal to 5? Explain why or why not. Are they? This is where we left off. We had x squared plus 4x is greater than or equal to 5, and we had 5 solutions, 2 positives and 2 negatives, that worked nicely. Now we're being asked to think about what happens if the equation is x squared, oops, excuse me, not x squared, x times the quantity x plus 4. Will those still be solutions? Let's think. If we put 5 in there, 5 times 5 plus 4 is greater than or equal to 5. 5 times 9 greater than or equal to 5. 45. Looks okay to me. I'm going to be lazy. Let's go ahead and put the -5 in there. -5 times -5 plus 4 is greater than or equal to 5. What we've got is -5 times -1, which is greater than or equal to 5. And that's also true. 5, negative times negative positive, and it is precisely equal to 5. So we got truths in 2 places. And really, if we think about it, if we really look at what we see here, if we look at this, if you think about it, this equation really matches this equation. If we were to do the distributive, x times x, we'd get x squared, and x times 4, we'd have 4x. So yes, well, we can't read that one. Let's get another color. Yes, these answers are great. These answers still work. I'm wondering if you know the reason why. I hope you wrote distributive. Apologies for the handwriting. I'm going to get better, honest. Should your 4 values also be solutions to the inequality 4x plus x squared greater than or equal to 5? Explain. Are they? Okay, this time we're being asked if the original values that worked for x squared plus 4x greater than or equal to 5 would be the same answers as 4x plus x squared greater than or equal to 5. I hope that you're noticing that the painful answer obviously is commutative. And it asks, are they? Well, we tried, let's go ahead and use 1 and -1 this time. Ooh, let's have another color. Why not? It's fun. So 4 times 1 plus 1 squared is greater than or equal to 5. 4 plus 1 is greater than or equal to 5. Yes. And 4 times -1 plus, protect your 1, -1 squared greater than or equal to 5. We have -4 plus -1 squared. Whoops, shoot, blew that one. Let me just get rid of this. -1 squared is 1. Oh, I could have just got rid of some of that, not all, but oh well. Here we go. plus 1 is greater than or equal to 5. And now, you know what? I didn't remember the right one to test. So this is negative, not 4, but 3, greater than or equal to 5. And we have a false. Actually, I'm not going to be unhappy about this because it just goes to show that what was false is still false. And we're going to say commutative saves the day. Commutative. And really, every time you do a math problem, what you're looking for is what was different and what was the same. We're going to take D and E together this time. Should your 4 values also be solutions to the inequality 4x squared plus x squared minus 6 greater than or equal to negative 1? And should they be solutions to 12x plus 3x squared greater than or equal to 15? Let's find out. If you're going to do a problem like this, one of the things you have to think about is what's the same and what's different. If we see 4x and we see x squared, and then we have this negative 6 that there isn't anything, and then we have 5 and negative 1. Well, that's kind of daunting, but really if you think about it, the difference is that let me get a color here. The difference is that we subtracted 6. So the question is this the same as 5 minus 6? Did we subtract 6 from both sides? And if we say yes, we can see that we have 4x squared plus 4x, excuse me, plus x squared minus 6 equals negative 1. That's a true, or greater than or equal to, true statement. And let's try negative 7 in here just for the fun of it. Remember, we knew that worked. Negative 7 plus negative 7 squared minus 6 greater than or equal to negative 1. Negative 28 plus 49 minus 6 is greater than or equal to negative 1. Negative 21 and negative 6 is positive 15. I can make this into a 15, which is greater than or equal to negative 1. True statement. We're happy. And it's the same thing here. Is this also true? Well, now we have a different problem. Here we start with 4 and we have 3. Here we have an invisible 1 and we have 3 again. I just told you the answer, but maybe you'll remember. Then we have 5 and 15. So the question is, what happened? And honestly, the answer is we multiplied everything by 3. But do the answers work? Well, let's see. Negative 5 was one we know works. Let's try. 12 times negative 5 plus 3 times negative 5 squared is greater than or equal to 15. Negative 60 plus 3 times, this is 25, is greater than or equal to 15. Hopefully you see that this is negative 60 plus 75, which is greater than or equal to 15. It's exactly greater than or equal to 15, but it is greater than or equal to. The equal to counts. We made it. Exercise 1.